so we're talking about radical expressions and rational exponents. So when we say rational exponents, we're just talking about exponents with fractions. And we're basically going to be simplifying. So it says the nth root of a real number a can be written as this radical expression, where n is the index of the radical and a is the radicand. When a number has more than one root, the radical sign indicates only the principal or positive root. So the nth root of a. And like I said, on your calculator, you can find the nth root on your math, and then you got number 5, gives us the nth root. So there are numbers and types of real roots. And these are all based on the index and the radicand. So if we have an odd index, we're always just going to have one real root. Okay? Because there's one number raised to that power, raised to a power that's going to equal that number. Okay? So like the third root of 8 is 2, because we could say that is the cube root of 8, and we know that's 2. Okay? If we have an even index, right, that's the root there, and a positive radicand, there would be 2 real roots. Okay, so like if we said the fourth root of 16, so if we said the fourth root of 16, okay, now this is going to be plus or minus 2. Now, we're talking about the roots of that number. We're not necessarily saying it is the fourth root of 16, but that's what we're looking at. So because, 2 to the fourth power is 16. So if I did 2 to the fourth, I get 16. And if I did negative 2 to the fourth, I would get 16. Okay, so the fourth root of 16 is a positive 2 or negative 2. If we have an even index and a negative radicand, there are no real roots. And that's because we can't take the square root, the fourth root, the sixth root, the eighth root of a negative number. Okay? Because if I try to do that in my calculator, fourth root of negative 16, we get non-real answer. Okay, because that would be where we would get I. Okay, a complex number. And if the radicand is 0, then there's only one root, and that is 0. Okay, so the 50th root of 0 is always going to be 0. All right, so finding real roots then. Says the sixth root of 64. So basically we're looking at this. We want to find out, okay, 6 is my index, and I want to know what is the sixth root of 64. Well, we just did x squared, x cubed, x to the fourth, x to the fifth. We didn't do x to the sixth. Okay, we could do that, or we can just stick this in our calculator, say, go to our math, number 5, and the sixth root of 64, and that is 2. Okay. So, 2 things we have to look at. All right. It says the sixth root, that is our index. And in this case, that means that the index is even. Okay. And it says of 64, all right, so that means that our radicand is positive. So if we have an index it's even and a positive radicand, then that means we're looking at this one right here, which means we're going to have 2 real roots. So when I do the sixth root of 64, I get 2, but in this case then we're talking about plus or minus 2 because we have an even index and a positive radicand. Okay. Letter B, cube roots of negative 216. Okay. So if it says cube root, that means I have an odd index for cube root, right? Because it would be cube root negative 216. All right. So if you go to your chart you just made, and it says cube root, so I'm looking at x cubed, all right? It's 216 under there under x cubed. It's 6, okay? So this is going to be negative 6. There's just one answer, all right? I could go to my calculator, do the cube root, negative 216, and it will give me negative 6. Letter C, fourth roots of negative 1,024. Okay, so once again we have fourth roots, so that's an even index. Okay. We've got negative 1,024, which is a negative number. So we're talking about even index, negative radicand, there is 0 real roots, okay? So there's no real roots. Okay? And so if you try to type in fourth root of negative 1,024 in your calculator, it's going to give you a non-real answer, all right? It doesn't work. All right, so anytime this index is an even number and this is negative, it's going to be a complex number if we actually wanted to simplify it, but we're not going to. Right? We see there's no real roots then. Okay. All right, so when it's asking you to find all the real roots, then we want to look at this chart, identify what kind of index we have, identify the kind of radicand, and then go from there. All right, so make sure that you've got, if it's even and positive, you've got plus or minus. If it's an odd index, we just have one answer. And even and negative, 0. No real roots. Okay. All right, simplifying radicals. The little more difficult radicals. So we did this in Algebra B in a couple different spots. And you guys have done it with square roots, and square roots are no big deal too because you've worked with them. Okay? But now we're going to look at it with higher powers than square roots. We're going to use nth roots. So when you're doing these, if you have numbers and variables, the first thing I'm going to do is I'm going to pull them apart. So here, the fourth root of 81x to the 12th, I'm going to rewrite this first of all as the fourth root of 81 and the fourth root of x to the 12th. All right. So I look at my chart, fourth root, or on my calculator, to the fourth power is 81 there. Okay, it's in our y3. Yes, it is. And the answer is 3. So 3 to the fourth power is 81. So this part here is equal to 3. Now, when we're talking about variables and exponents, we're always looking for multiples. Okay? So if whatever my index is, I want multiples of that number. Right? So to get 12, I have, how many times can I have 4? 3 times, okay, because I got 4, 8, then 12, okay? So I can do this 2 ways, all right? So I can think of it as the 4th root of x to the 4th, 4th root of x to the 4th, 4th root of x to the 4th, okay? I can think of it that way. And so this would give me x and x and x. So if I multiply them together, we get x cubed, right? Or the other way you can just think of it as, what is 12 divided by 4? 3. So we would have 3x cubed is the simplification of that. Okay. That's one way you can think of it, okay? Another way we could think of it as, we could say, all right, so this is the 4th root of x to the 4th and to the 3rd power also. Okay. So this would simplify to be x and cubed. So there's a couple different ways to think about it. And when we start looking at the rational exponents, we can think of it another way, because this, we could actually think of it also as x to the 12 over 4 power. Okay. And 12 divided by 4 is 3, so then we have the x cubed. But we'll talk about that more in a minute. Okay. All right, letter B. The 4th root of 162x to the 9th over 16. So back when we were working with just square roots, we would get situations like we did in the warm-up, the square root of 12. So we say, okay, what's the largest number that goes into 12? The largest square into 12, and say, okay, that's 4. So I could rewrite this as square root of 4 times square root of 3. Square root of 4 is 2, and then we're left with square root of 3. Okay? So we're going to do the same thing with bigger indexes than 2. Okay? So first thing I'm going to do is I'm going to pull this apart into 3 pieces in this case then. Right? Because we have the fraction plus we have x. So I'm going to rewrite it as the 4th root of 162, 4th root x to the 9th, and the 4th root of 16. All right, so let's look at our chart for numbers and the 4th power. Okay, is 162 there? No. Okay, is 16 there? Yes. Okay, so the 4th root of 16 is what? All right, so I want to simplify that part right away so I can at least make this a little bit easier. So the denominator is 2. So what we need to look at now is, since 162 is not there, right, so we're looking at y3, right? So does 1 go in 162? Of course it does. Okay. Does 16 go into 162? I'll take my calculator, go back to my home screen. 162 divided by 16. Okay. Oops, 162 divided by 16. Okay, all right, that's not a whole number. All right, so what's the next number then? The next number is 81, right? All right, so we'll try 81. 162 divided by 81. Wow, look at that. 162 divided by 81. Right? And we get 2. Oh, nice. Okay, so then I'm going to rewrite 162 as the 4th root of 81 times the 4th root of 2. All right, just like we would do it with the square root of 12. We'd say that's the square root of 4 times the square root of 3. Okay, x to the ninth power. All right, is 9 a multiple of 4? No, it's not. Okay, what's the multiple of 4 that's just less than 9? It's less than 9. 8 is. Okay, so I can rewrite x to the ninth as the fourth root of x to the 8th and the fourth root of x. Okay, so 81 times 2 is 162. X to the 8th times x is x to the ninth. But we want these to match up. All right, so what do we know? The fourth root of 81, we found out that that is 3, right? Fourth root of 81 is 3. So we have in the numerator, we have 3, not 8. Right? And so we focused on this part first, right? Because I know that value is 3. Okay. What is this one here then? What's the fourth root of x to the 8th? 8 divided by 4 is 2, so that's x squared. So we get 3x squared. Those two parts I can simplify. All right? I can't simplify these two, so I'm going to put them back together. So there will be and I'm going to use parentheses so I don't look at these things wrong. So I have the fourth root of 2 and x. And that's divided by 2. All right, so we have to take our time with them, simplify them one by one, all right, and then find our answer. All right, so let's do a couple of these then. I don't even know if they're going to be that hard. All right, so doing the cube root of 16x to the 8th over 27. So we've got the cube root of 16, cube root of x to the 8th, and the cube root of 27. All right, so 27, we know that's 3. Okay. 16 there's no cube root of 16. All right. But 8 goes into 16, so we can rewrite this as the cube root of 8 and the cube root of 2. X to the 8th, right? That would be the cube root of x to the 6th, all right? Because 3, 6, 9, we're looking at multiples of 3 for our powers. And then so I have x to the 6th, and I have x squared left over, right? So I would also have the cube root of x squared here. And the cube root of 27 is 3. So these two both simplify. Cube root of 8 is 2. Cube root of x to the 6 is x squared. Okay, those two both simplify. And then I'm going to put what I have left then, these two pieces, I'm going to put those together. So we have the cube root of 2x squared left over that I can't simplify over 3. So this would be our answer. It's a little complicated, all right? But it's just a matter of taking your time, focus on one piece at a time. Okay? All right, now, letter C. How did we do on letter C? Did we get that one? Okay. On letter C, you actually have to do the multiplication first. Okay? Because this is the cube root of x to the 9th. Right? X to the 7th times x squared is x to the 9th. Since these are both cube roots, I can multiply what's under the index together. So then that's x cubed. All right, so most of them aren't too bad, but some of them get a little bit tricky, like this our example B and then letter B there. So you have to be careful then. All right, so let's just do a quick little run through of the other three examples then. Examples 3, 4, and 5. Okay, rational exponents. Those are fractional exponents. And when we have a rational exponent, the denominator of the rational exponent is the index. Okay? The denominator of the rational exponent is the index. So if I have algebra terms here, if I have a to the power of 1 over n, then that's the nth root of a. If we have a to the power of m over n, then like I showed you earlier, we can write this then. So if we have a to the m over n, we can put m outside of the whole radical, or we can put it inside with the radicand. Okay? It can go either of those two spots. But the denominator, which is the index, is always going to go in that spot for the radical. Okay? So we were talking about in the what you did yesterday, we had 32 to the 3/5, didn't we? Okay, and we already talked about that problem. But here's negative 32 to the 3/5. Okay? So the big thing is with these problems then is that we're going to look at, so in this case the denominator is 5, so that's the index. So I have the 5th root of negative 32. Okay? So first what I want to do is I want to focus on that. Okay? And so I'm going to look on my 5th power, which is our y4. Okay? Is 32 or negative 32 there? Okay? So we're just looking for the positive numbers. If the positive number is there, then the negative number is going to be the same one. Okay? And so 32 is there, and it's when x is 2. So since I can simplify the 5th root of 32, that means then that I want to put the exponent, or the numerator of that exponent then, on the outside. Because I know I can simplify the 5th root of negative 32, so then I'm just going to raise that to the power of 3, which gives me negative 8. Okay. Now that's one method of doing it. Okay. The other method of doing it would be this way. And this would mean that I would do negative 32 to the 3rd power and then try to find the 5th root of that. Okay, which is more difficult because negative 32 to the 3rd is a big number. Okay, now, reality. Okay? I can put negative 32 to the 3/5 in my calculator. All right? So this is one of those situations where whether you can write it in radical form or not, okay, is one thing. But the second thing is that you can stick that in your calculator and find an actual answer. So I could go to my calculator, go to my home screen, put in negative 32 raised to the power of 3/5, and it will give me negative 8. Okay. So I can put that into my calculator, and so then which way you write it here, does it matter? Yes, it does, because I really want to see this simplification then, okay, like we have here on the left side, so that you can do that. Okay, so the index is the denominator. Okay? The numerator then we're just raising to that power. Okay, all right. So here we have them written as radicals, and we're going to change them to rational exponents. Now the reason that I actually like these is that we can go back to the ones we were working on earlier and actually think about them with rational exponents instead of doing them as radicals. So my base is 13, and I'm going to have a rational exponent, so a fractional exponent. The index is the denominator, and any other power, whether it's under the radical or outside the radical, is the numerator. All right? So this simplifies to 13 to the 1/2 power. Which would be the square root of 13. Okay? Which we don't need, but. This is why I said back here, so okay. All right. Well, I'm not sure about this 4th root of x to the 12th. Okay? So if I wrote it as x to the 12 over 4, then, okay, that's easy to simplify because 12 divided by 4 is 3. Okay? So when you're looking at these, you can actually look at these using those rational exponents also. Okay. Now, letter B, 13, the index is 5, that's the denominator. So we get 13 cubed, which that number then I can type in my calculator. Right? And the thing is, all of these can go in your calculator. Right? But unless you can simplify it to a specific number, okay, a whole number, then we're going to leave it with the rational exponents. Right? So I could go to my calculator and do the math, number 5, 5th root of 13 to the 15th power. All right, and we get 2,197, which is the same as 13 cubed. All right, so our calculator will do these, right? But like it says, write it as rational exponents, right? And then you could use your calculator if you want to check them. Then the last example was basically just using rules of powers, which we've done these before. We did them with our logarithms, okay? And now we're just doing it with rational exponents. And so if we multiply with the same base, we add the exponents. If we divide with the same base, we subtract the exponents. Okay? And all the other power rules apply also. So like on 5b here in the, well, here we have the -1. So let's take a look at these three real quick then. So you can write them or not if you want to. All right, so 7 9th, 7 raised to 7 9th times 7 raised to 11 9th. My base is 7. And since I'm multiplying with the same base, we add the exponents. So 7 plus 11 is 18 over 9. So that's just 7 squared, or 49. Letter B, 16 to the 3/4 over 16 to the 5/4. So here we're dividing with the same base, so we subtract the exponents. So that's going to give us a 1 in the numerator and 16 to the 2/4 in the denominator. All right. Well, we know that 2/4 is 1/2. What's 1/2 power the same as? Square root. Okay, so this is the square root of 16, and the square root of 16 is 4. So this is just equal to 1/4. All right, and then let's look at B here because of the negative exponent. So whenever you have a negative exponent, We take the reciprocal, make it positive. So this is going to be 1 over negative 8 to the positive 1/3 power. And 1/3 power is cube root. So this is the same as 1 over the cube root of negative 8. So that's going to be negative 1/2. Because the cube root of 8 is 2. Cube root of negative 8 is negative 2. Okay? All right.